All right, in this video, we are going to move into section 3.5, which is the second section that talks about optimization. Instead of doing just absolute maxes and mins, in this section, we're going to do business, economics, and general applications. Now, this section is still about maximizing and minimizing stuff, but it's going to be more than just functions. We're going to maximize and minimize certain word problems and formulas that are already provided. So if you need to pause the video to write all this down, please do that. I'm going to run through this really quickly, but essentially this is kind of my own setup strategies of how I solve optimization word problems. So run through this really quickly. Number one, obviously, read the problem carefully. If relevant, I will make a drawing to kind of relate everything. I'm going to make a list of the appropriate variables and constants, noting what varies, what stays fixed, what units are used. And then if I did a drawing, I'm going to label my measurements if one exists. We're going to translate the problem to an equation involving a quantity Q that needs to be maximized or minimized. So the function that needs to be maximized, if it's not already called something else, we're going to default and call this Q. And then we're going to try to represent Q in terms of the variables of step 2. So we need to turn Q into one variable that matches all the way across. To do this, we will use algebra and substitutions as needed to express it as one variable. That is the key. Everything has to be in terms of the same letter before you can move on to the biggest and most important step, which is number 5. You need to use the procedures that we covered in 3.1 through 3.4 to figure out the maximum or minimum values and the points at which they occur. So I'm not going to follow this strategy to a T every time, but this kind of gives you an idea of the thinking I'm doing as I start to work these problems in this video. So for example, let's look at number 1 here. Of all the numbers that add up to 70, can you find a pair that has the maximum product? So when I read a problem like this, I'm trying to write out equations. In this case, drawing a picture is not very helpful, but can I write out equations that talk about what this is? So the first part of the sentence says, I need to have two numbers that add up to 70. Now, I have no idea what those numbers are. So for right now, I'm going to say that they're called X and Y. I need to find two numbers. We don't know if they're the same or not for right now. So we're going to say that X plus Y has to be 70. I need those two numbers to have a maximum product. This is the thing that I'm trying to maximize in our equation. So like I said earlier, if it's not naturally called something else, I'm going to call it Q. Well, product means multiplication. So essentially, I need two numbers that add to 70, and then when I multiply them together, they form a maximum product. So I'm going to say Q is equal to X times Y. The issue is that I don't know how to maximize something that has two different letters in it. So my next challenge is you have to change one of the letters into the other one. Naturally, we like to keep X's in the problem, so I'm going to usually always try to change Y if possible. So I need this Y to be in terms of X. Well, I can do that by going back over here to the left, and let's solve for Y in the first equation that I wrote. If I move the X over, I can say that Y has to be 70 minus whatever X is. And if I substitute that into my Q function, I can say that Q is X multiplied by 70 minus X. If I distribute that X through, this will be 70X minus X squared. And this is now something I know how to maximize or minimize. In this case, it's maximize. I need to find the critical values like we've done all throughout chapter 3. So I'm going to find Q prime, which is 70 minus 2x, and I'm going to set that equal to 0. If I move the 70 over, that would be negative 2x equals negative 70. And if I divide both sides by negative 2, I can see that x is 35. So that is one of my numbers for this problem. Most of the problems we're going to see today are going to ask for multiple different numbers. In this case, I need the y value as well. So once you solve for x, now I'm going to substitute that value back into my y equation over here to find that value. So y is going to equal 70 minus 35. So just by coincidence on this problem, x and y actually end up being the same thing. So the two numbers that add up to 70 and give you the biggest product when you multiply them together is 35 for x and 35 for y. That is the idea behind the problems we're going to see today. Two equations, you have to use both of them simultaneously to help you maximize or minimize a value. All right, let's look at a second one. I would like you to maximize the equation b equals x times y squared, where x and y are positive numbers such that x plus y squared is 1. So to kind of write these in the same form we had in a minute ago, I know that the following equation has to be true. I know that x plus y squared must equal 1. And they called it b this time, but we don't treat this any differently. We're trying to maximize the equation x times y squared. Once again, I can't maximize this with two different letters. So naturally, I'm going to try to get rid of this y squared. I can do that by solving for y squared over here. Now, you could also do this in x's. I'm trying to keep everything the same way. That way I don't lose anybody. So I'm going to isolate the y squared. If I move the x over, I can say that y squared is equal to 1 minus x, that I can now substitute back into my formula for b. So b will become x multiplied by the equation 1 minus x. I can distribute that x through to make it x minus x squared. And that is something I can now find a critical value for. So b prime is going to be 1 minus 2x that I'm going to set equal to 0. If I move the 1 over, negative 2x equals negative 1. And if I divide both sides by negative 2, x has to be 1/2. So I now know half my answer. To get the y value of this problem, I'm going to substitute this back into my equation. And we'll have y squared equals 1 minus 1/2. So y squared is equal to 1/2. And when you take the square root of both sides, you will end up with technically y equals plus or minus. The square root of 1 is 1, and root 2 is an irrational number. If I were to rationalize this like you do in an algebra class, I would multiply the top and bottom by root 2, and you get plus or minus the square root of 2 over 2. Now the question becomes, how do I know which one it is? Well, back in the original problem, if you notice right in the middle, it says x and y need to be positive numbers for this to work. So therefore, I know by default the negative answer can't be correct. So my y value thus has to be y equals the square root of 2 divided by 2. And those are the two values that will maximize that b equation. Let's do one more just like it. This one actually involves, I think, a chain rule idea. So I wanted to make sure I did this in the video for you as well. So number 3, minimize the equation e equals x squared plus 2y squared, where x plus y needs to equal 3. So let me put this in the same form again. I know that x plus y has to be 3. And we're trying to minimize the equation x squared plus 2y squared. Now, once again, I don't like this y here. Unfortunately, I can't get rid of the entire y squared at once because there is no y squared in the other expression. So all I'm going to concentrate on is let's substitute this just y. I can do that by solving for y in my first expression. which will be 3 minus x, and substituting that into my e equation. So e will be x squared plus 2 times 3 minus x all squared. And this is something I can take the derivative of. E prime will be 2x. This is going to be the chain rule. So bring the 2 to the front. That's 4. Leave the inside alone. Subtract 1 from the power, which makes it a first power. And then multiply by the derivative of the inside, which is negative 1. Got a little bit of cleaning up to do here. So this would be 2x. 4 times negative 1 makes that a negative 4 times 3 minus x. So this comes out to be 2x minus 12 plus 4x, which when all is said and done and I put everything together, I get 6x minus 12 as my e prime function. I am now going to set that equal to 0 to get the critical value. So add 12 over, so 6x equals 12. Divide both sides by 6, and our x value has to be 2. To get the y value, I'm going to substitute this back into my y expression on the far left, and I can say that y is equal to 3 minus 2, and thus y has to be 1. And that makes sense. 2 plus 1 would be 3, and these two numbers would minimize the equation for e. All right, now that we have kind of this idea down, now we're going to move into some more word problem ideas and applying the same thing. So let's look at number 4 here. And this one you're probably going to need a calculator for because I think the numbers come out a little bit ugly, but we'll get through it together. Number 4 says open air waste management is designing a rectangular construction dumpster that will be twice as long as it is wide and must hold 12 cubic yards of debris. Find the dimensions of the dumpster that will minimize its surface area. So this time I pulled a picture out of the book, and I apologize for it being a little blurry, but this is the idea. You have this rectangular dumpster that has no lid, and we know a few things about it. Number 1, it's listing its width as being X. So if you can't tell, this is the width of the dumpster. In my problem, it says that the dumpster must be twice as long as it is wide. So this first question mark down here by the 1-800-NO-WASTE, this is going to be my length. And if the length is twice as the width and the width is X, that means my length has to be 2X. It doesn't say anything or describe anything about the height of this dumpster. So by default, it's stuck being my other letter, which I'm going to call Y. All right. One number that's given to us in the problem is that this dumpster must hold 12 cubic yards of debris. If you recall from a previous class, maybe even in high school, cubic means volume. So I need to be able to find the volume of this three-dimensional rectangle. So from a geometry or maybe even an algebra class, you probably remember that the volume of this kind of shape is your length times your width times your height. Since I know what length, width, and height are, I can plug those in. This would be 2x times x times y, which simplified gives me 2x squared times y. That is my formula for the volume of this. But remember, I know the volume equals 12, so therefore 2x squared y has to equal 12. Right? We want to minimize the surface area. So this is the part where you're going to develop a surface area formula. You can call this whatever letter you want. Just to make it the letter, I'm going to call it A for area. So remember, surface area means you need to add up all the sides of this dumpster. All right. So there are 5 sides. There's the 4 walls, and then there's the bottom of this dumpster. The bottom of the dumpster is a side by itself. So if you're thinking about the bottom of this dumpster, where my arrow's pointing, the bottom of this dumpster has a one side which is represented as 2x, and it has another side represented as x. So to get the area of the bottom of the dumpster, I have to multiply 2x by x. If we look at the 2 smaller sides of this dumpster, so that's the side over here on the far right, and then the side over here on the back that we can't see. Both of those areas have to be the same thing based on the dimensions. So I know that there are going to be 2 different small rectangles. These smaller sides have one side is equal to x and one side equal to y. So if I were to multiply those dimensions together, that would just be x times y. Once again, the 2 in the front is because I'm doubling it because there's 2 mirror images. The same thing can be done for the bigger sides of the rectangle. You have this side that says open air waste. It has an identical side on the other part of this that you can't see on the graph or on the picture. There are 2 matching sides. You need to find the area of each of these, and then we'll double it. So this bigger rectangle has one length as 2x and has one side as y. So that would be 2x multiplied by y to get the area of one of them. We double it, or the 2 in the front, to get the other side. If I were to clean this up, this would be 2x squared plus 2xy plus 4xy, which then combines into 2x squared plus 6xy. This is my surface area formula that I need to minimize. But the same issue we had earlier is that I can't use this y that's in my final formula. If I take the volume formula, though, up here in red, I could solve for that y and then substitute it in. So from this formula, if I were to solve for y, dividing both sides by 2x squared and simplifying would give me a y expression of y equals 6 divided by x squared. I can substitute this in for y, and I will have a new surface area formula. This will be 2x squared plus 6x times 6 over x squared. Simplifying this gives me 2x squared. Let's see. This x cancels one of those x's and gives me 36 over x. This is the formula that I need to take the derivative of to find the critical values. Now, before I do that, I'm going to rewrite this as 2x squared plus 36x to the negative 1 to make the derivative a little bit easier. So a prime is going to end up being 4x minus 36x to the negative 2. And if I rewrite this, it is 4x minus 36 over x squared. That is the derivative of my surface area function. To find the critical value, I need to set this equal to 0. So I'm going to multiply the entire equation by x squared. We saw this idea in a previous section. I think it was in the section 3.4 video. If I multiply everything by x squared, I end up with the following. I get 4x cubed minus 36 equals 0. If you move the 36 over, you get 4x cubed equals 36. And if you divide by 4, you get x cubed equals 9. Taking the cube root of both sides here, we can get our first answer that x is going to be, give me 1 second, type this in my calculator. The cube root of 9 is going to be approximately 2.08. And if you look at all my original labeling here, that means that the width of my structure has to be 2.08. If I want to find the length, remember the length is 2 times x, so I can do 2 times 2.08, which is 4.16, so that would be the length. And then the height is my y equation, so height is equal to y, which is equal to 6 over x squared. So that comes from the red formula at the very top. If I plug my x into that, that gives me a height of 1.39. And these are the dimensions of my big trash can up here, I guess, whatever they call it in the original problem, construction dumpster. This dumpster has dimensions of width is 2.08, length is 4.16, and the height is 1.39. Probably the worst problem you'll see on your assignments. It's a lot of tedious work, but just take your time, follow through with this video, and you'll be able to get the one on your homework and quiz correct. All right, so let's look at number 5. So some more word problems, but a little bit more reasonable. It says Bulldog Industries plans to enclose 3 parallel rectangular areas for sorting return goods. The 3 areas are within one large rectangular area and 1,200 yards of fencing is available. What is the largest total area that can be enclosed? So if you're looking at this picture over here on the right, let me kind of label what it's talking about. So we know we have 1,200 yards of fencing to use. Based on this rectangular shape, what do we know about this? Well, I know that this side, this side, this side, and this side, which are all part of the fencing, all have to be the same length. So I'm going to call those X. This side and this side, you can obviously see are a lot longer and are not going to be the same thing as X. So we're going to call each of these sides Y. If I have to use the 1,200 yards of fencing on all 6 of these parts, I'm going to add them all together. So I know that the 1,200 yards of fencing has to end up equaling, when all is said and done, the 4 X's that I have labeled plus the 2 Y's. Now, according to this problem, you're trying to find the largest total area. So I want to write an equation that represents the area of this rectangle. Now, from geometry, area of a rectangle is length times width, and it looks like, if I were to label some more stuff here for you to see, the length of this rectangle is y, and the width of this rectangle is x. So if I were to multiply those together, that means my area formula is just x times y. And for the 3rd or 4th time in a row, we have this letter that we can't use because I need to take the derivative of a, but I can't do it with a y sitting there. So back to my original formula that has all the numbers. I need to solve for y in this formula. If I move the 4x over, 1,200 minus 4x is going to equal 2y. And then if I divide everything by 2, I can say that 600 minus 2x is equal to y. We're going to substitute this into our area formula. So area will be x times 600 minus 2x. If I distribute the x through, this will be 600x minus 2x squared. And now I can find the critical values of this. So a prime is going to be 600 minus 4x that I'm going to set equal to 0. I'm going to move the 600 over. So negative 4x equals negative 600. And if you do negative 600 divided by negative 4, that's going to be 150. Plug this back over here to figure out what y is. So 600 minus 2 times 150 is y. So this would end up being 300 equals y, and we now have our two parameters. But in this problem, it doesn't ask for the dimensions, it asks for what is the total area, the part I have boxed in red at the very top. So I need to use my area formula, which is x times y, and I can find my total area. So x we found to be 150, y we found to be 300. If you just multiply those together in your calculator, you will get a total area of 45,000. So sometimes you have to pay attention to the word problem to know what part you're looking for. All right, so we're about to get into a few business applications here. So I wanted to spend a couple seconds reviewing some formulas you should remember from previous videos. And if not, you need to pause the video and write them all down again, that's fine. So really quickly, remember that capital C of X is the total cost function. We'll see that some more today. If I ask you for average cost, that's represented by C bar. Capital R of X is the total revenue function. Capital P of X is the total profit function, and little p of X is the price function. Now, if those are given to you, fantastic. A few of them may not be given to you, and you may have to find yourself. So remember from a previous section, revenue can be found by taking X times the price function. Profit can be found by taking your revenue function minus your cost. And average costs can be found by taking the cost function and dividing it by X. So if these three things aren't given to you, they can be found by using any of these three formulas. So we're going to use these ideas over the last few word problems in this section. So let's start with number 6. Find the maximum profit and the number of units that must be produced and sold in order to achieve this profit. So big thing I realize in this problem is that everything is talking about profit. Well, I don't have a profit function in this problem. We have a revenue and a cost function. So the first thing I'm going to have to do is use my formulas and say that profit is equal to revenue minus cost. I need to plug my two functions into this. So profit is equal to 2x minus 0.01x squared plus 0.6x plus 30. I put that in parentheses because I have to distribute this negative to all three terms of the cost function. So that would be 2x minus 0.01x squared minus 0.6x minus 30, which if you combine your like terms, you'll have negative 0.01x squared. If you put the x's together, that's plus 1.4x and then minus 30. So this is your profit function. I'll put a little parentheses by it. The problem says is to maximize your profit. So I need to find the critical value of my profit function. So P prime of X would be equal to negative 0.02x plus 1.4 that I'm going to set equal to 0. If I subtract the 1.4 over, you should have negative 0.02x equals negative 1.4. And then if I take negative 1.4 and divide it by negative 0.02, you should get an x value of 70. So one of the questions we have now answered. The number of units that you have to sell to maximize your profit is 70. It also asks for the actual maximum profit. So you need to take the 70 and plug it back into the profit function we found here in blue. So capital P of 70 would be negative 0.01 times 70 squared plus 1.4 times 70 minus 30. And then I can type all this in. So give me a second here. That gives me, a big profit here, a profit of $19. So a lot of the problems that I've made up are not realistic. They're just more to make sure the numbers come out nice, or at least as best as possible. But that's your idea. It takes 70 items to maximize your profit, and you will maximize your profit to be $19 if you produce and sell 70 items. All right, number 7 is a multi-part question. I'll have to do it over 2 slides to have enough room here. So here we go. It says Riverside Appliances is marketing a new convection oven. It determines that in order to sell X ovens, the price per oven must be P of X equals 280 minus 0.4X. It also determines that the total cost of producing X ovens is given by C of X equals 5,000 plus 0.6X squared. Part A, what is the total revenue function? Now, I didn't give you what revenue is, so from our formulas from earlier, we can say that revenue is equal to X times your price function. Now, I did give you a price function up here, so I can write this as X times 280 minus 0.4X. And if I distribute that X to both terms, that is 280X minus 0.4X squared. That, or this, I guess I should say, is your revenue function. Part B says, find the total profit function. So from the last problem we did, hopefully you remember that profit is found by taking your revenue function, which we actually just found, and we're going to subtract the cost function that was given to us above. So the revenue function we just found was 280X minus 0.4X squared, and I'm going to subtract the cost function, which is 5,000 plus 0.6X squared. Distribute that negative through, and you'll get a minus 5,000 minus 0.6X squared. And if you put your terms together like terms, putting your X squared terms together, you should get just a negative 1X squared, or just negative X squared. Then you have plus 280X, and then you have minus 5,000. This is your profit function. And so that is parts A and B. C through E is on the next slide that I'm going to go to, but I'm going to also be bouncing back and forth a little bit because I don't have all these numbers memorized, so I'll have to go back and forth to get everything written down. So let me read through the last 3 things we have to do, and then I'll do a little bouncing around. On part C, I'm going to figure out how many convection ovens must be produced and sold in order to maximize profit. On part D, I'm going to find that maximum profit. And on part E, I'm going to figure out what price I should charge per oven to maximize the profit. Now, I need to maximize profit on part C, and how many items I need. Well, I'm going to need the profit function from the slide we just did. So let me bounce back really quick. That is negative X squared plus 280X minus 5,000. So that was my profit function. To maximize this, I need the critical value. So I'm going to take the first derivative of my profit function, which is negative 2x. Oops, sorry, I lagged a little bit there. Let me back up a little bit. So that's negative 2x plus 280. And to find the critical value, I need to set that equal to 0. If I subtract the 280 over, I will have negative 2x equals negative 280. And if I divide both sides by negative 2, the answer to part C is 140. So I need to sell 140 convection ovens to maximize my profit. Part D is asking for what's that profit going to be. So I would need to plug the 140 back into the profit function that I found on part B. So I would calculate what is P of 140, which would be negative 140 squared plus 280 times 140 minus 5,000. And so getting my calculator out here. Let's see, plus 280 times 140 minus 5,000 gives me a profit of $14,600. And once again, all I did was plug the X value I found in part C, excuse me, into the profit function I found on part B. Part E says what price per oven will maximize the profit. Well, in order to do this problem, I'm going to need to remember what my price function is, and that was on the last slide. So back at the very top, price is 280 minus 0.4x. Well, if this is your price function and you're trying to maximize profit, this time you need to plug some number into your price function. That's actually going to be the same x value that you found on part C. So little p of 140 would be 280 minus 0.4 times 140, which would be $224. So you would need to charge $224 per oven to achieve this maximum profit. All right, and then last but not least, one more word problem to end this video. This one's got a lot of moving parts, so we kind of save it for the end so we can talk through it together. Let me read the whole problem, and I'll show you how we work this. It says the Doghouse Inn is a 300-unit luxury hotel. All rooms are occupied when the hotel charges $80 for a room. For every increase of X dollars in the daily room rate, there are X rooms vacant. So let me pause there for a second. So what this is saying is that if you charge $80 a room, you will sell out your hotel every time. We're going to, once again, it's all about making money. What this next sentence says is that if you were to, every dollar you raise your rate, that's how many rooms you're going to have vacant. So if you were to raise your rate up to $85, so $5 extra, you're going to lose 5 rooms and they're going to be vacant. So you won't make the money off that room. You also know that each occupied room costs $22 per day to service and maintain. The question is, what should the hotel charge per day in order to maximize profit, and how many rooms will be occupied when the profit is maximized? So we have a lot of information we've got to figure out here, but as you can see at the very end, it's all about profit. So we're going to have to end up developing a profit function in order to do this problem. We don't have revenue given to us and we don't have costs, so we're going to have to figure this up ourselves. So if you remember, revenue normally is found by doing X times price. Now, X is the number of units you're going to sell, and P is your price function. So we're going to have to develop both of those ourselves. So if X is the number of units that you plan on selling, well, according to this, the number of units you're going to sell is going to be 300 rooms, because that's how many rooms you have, but you have to subtract off how much money you're going to raise your rate. So we're going to subtract off the number of rooms, which equals the rate you're going to increase. Your price function would normally be $80, but since you're going to talk about raising your rates, this would end up being $80 plus however much you end up adding on. So as you can see, however many dollars you add to the price function is how many rooms you have to take away from the units. So using these two functions, I can actually now write my revenue function. My units would be 300 minus X, and my price would be 80 plus X. Doing a little number crunching here, so let me multiply this all out. This would be 24,000. Let's see, outer, inner, that would be plus 220X minus X squared. So this is my revenue function. For cost, it says you have to charge $22 per day to service and maintain. Now, we don't know how many rooms we're going to have. We know the number of units we plan on selling is going to be this formula 300 minus X. So however many rooms this ends up being, we have to charge $22 per room. So I need to distribute the 22 to both terms here. So 300 times 22, this would be 6,600 minus 22X. All right, now that I have a revenue function and now that I have a cost function, I can now start to work on this problem. Next thing I need to do is find my profit function, which is revenue minus cost. So this would end up equaling 24,000 plus 220X minus X squared, and then subtract my cost function, which is 6,600 minus 22X. Distribute that negative through, and you get 24,000 plus 220X minus X squared minus 6,600 plus 22X. And then if I put my like terms together, this is negative X squared. That's going to be plus 242X. And then 24,000 minus 6,600 is plus 17,400. That is my profit function. I need to maximize that function. So now I'm going to find P prime of X. This will be negative 2X plus 242 that I'm going to set equal to 0. If I subtract the 242 over, that would be negative 2X equals negative 242. And then dividing both sides by negative 2, I get an X value of 121. Now, I'm not going to box anything in yet because I got to go back and answer the questions from the beginning. So let's scroll way back up and let's read the two questions. The first question is, what should the hotel charge per day to maximize profit? Well, that means I need to maximize my price function. So little p of X from up here is 80 plus X. And the X that we have to use is the 121 that we found down here, because that number is going to maximize your profit. So little p of 121 is 80 plus 121, which means we need to charge $201 per room. The last question is, how many rooms will then be occupied when the profit is maximized? Well, that's the units. So X, which is your units, is solved to be 300 minus X. So I'm going to take this same 121 and now plug it into my units function. So 300 minus 121 means that I'm going to end up, not money, sorry, it's not a money problem. You're going to end up having, it looks like 179 units occupied. So based on all this information, there was a lot of moving parts that we talked through. If you want to maximize your profit in this hotel, you need to only sell 179 units at $201 a piece. That will maximize all your stuff. So that ends this video on section 3.5. It was the second section of optimization. In the next section, we're going to move into a different kind of word problem called marginals that involves us talking about approximations a little bit. So I'll see you in the next video.